In this video, we're going to look at the meanings of the equal sign part 2. So compared to the last video, now we're going to look when we have variables in our expressions. Okay? So first, starting with perform the indicated operations or simplify. So here we have x plus 2 plus x plus 1, and we're told to add in this case because that's all the operations are addition. So adding means combining two or more quantities. We can add 1 plus 2 like we would in arithmetic, okay, and we have the commutative property, so we can move these around, and that would be 3. Since we do not know the value of x, we can't compute a number, but we can say that the sum of two x's is 2 copies of x, or 2 times x, which we are going to write as a 2. This is, we say, juxtaposed, juxtaposition. They're written right next to each other, and that implies multiplication. So just to connect this to arithmetic, remember, if you had 2 times 5, you could say that's 2 copies of 5, or adding 5 to itself twice. So we could say that in this other direction, x plus x is 2 times x. And we're going to look at this in another way in a video soon where we use the distributive property. But I think you can see that this is true. Okay. So there we performed all the operations we could. Notice there's addition left, and there's still something we can't, an addition we can't perform. This is our final answer because we have a variable term. Okay. Now, here we're told to simplify, okay, and that's similar, and it specifically means to perform any operations we can. This is the simplest form possible. Okay, so these directions, perform the indicated operations, simplify, basically mean the same thing. Okay, now looking at equivalent expressions, we saw this was a little bit different with numbers, and it's the same idea with expressions. We're going to be a little bit more specific with our definition of expressions being equivalent, though. Two expressions are equivalent if when you replace the variable with any number, the two expressions are always equal. Okay, so we can, to make an equivalent expression, 2x plus 3, what we found here, is an equivalent expression, but there's lots of different equivalent expressions. So you could also think of these as kind of the string of computations you might do when you simplify. Okay, here we added the x's, but we didn't add the numbers. Here we added the numbers, we didn't add the x's. Here we were tricky, we left the x's alone, and instead of writing 2 plus 1 equals 3, we wrote 7 minus 4, which is also equal to 3. So all of these are different equivalent expressions. Now evaluate an expression. So this seemed identical to simplifying or performing the indicated operations when we add numbers, but it really means something else in algebra. When you're asked to evaluate an expression, you're given a value for at least one variable. You will have equations with more than one variable later, but you're given a value, and it means to replace the variable with that value and then calculate or do the arithmetic, so simplify. Okay? So evaluating means to calculate. When you are given a specific value for x, you can replace x with the given number and perform the indicated operations. So here, there is our algebraic expression. We replace both of the x's with 4's, so these are equal given that x equals 4. Okay, so that's a truth assumption we make, so we can say that these are equal. And now you add them all together. 4 and 2 is 6, and 4 is 10, and 1 is 11, and compute. Okay. And now solve the equation for x. So x plus 4 equals 7. This means to find the number or numbers if one exists. So we saw in some cases, I think we had a plus 2 equals a plus 1. That was always false. We can never find a solution. So that's why I wrote if one exists. That make the truth value of the equality statement true. And this happens to be conditionally true. X plus 4 equals 7 only when x equals 3. Okay. So now let's look at some of these types with balance scales again. And we are going to state whether we're simplifying, evaluating an expression, finding an equivalent expression, or solving. Okay. So here we have x plus 5 equals 7. So I'm going to make this x and this 5. That's the left-hand side. The right-hand side is 7. Okay. So I think you can see that In order to add something to 5 and get 7, that something would need to be 2. We're going to do this more formally later, but don't discount the power of being able to visualize these equations and see what the solutions are. Okay, so notice we solved for x. Okay, and again later on you'll be given this and you'll be told solve for the variable. Okay, but now we're just getting a feel for it. Here, evaluate the expression when x equals 1. So here we're explicitly told to evaluate, so we know that the equal sign means to evaluate, which is replacing the variable with the given number. And I will just do that here. So we have, instead of x, I wrote a 1, 3, and now we have 2x, which would be 2 times 1, which is 2. So this left-hand side adds up to 6. Okay. So notice, evaluating is replacing the letter with the given value of the variable. Okay. And then you're basically performing the operations or simplifying. 1 plus 3 plus 2 is 6. Now, here we have two expressions. We have more than one x on each side. Let's take a look at this. So here, we're told that these are equal. So I can just put these. I have 2 x's and a 3 on the left-hand side, and a 12 and an x on the right-hand side. Okay. So let's use that idea that we used before. Since there's an x on both sides, if I remove an x from both sides, so let's just float those up to the sky, I think you'll agree that this is still balanced. I remove the same amount from both sides. So now we have x combined with 3 is equal to 12. Okay, so what number do I add to 3 to get 12? Equivalently, you could say, draw some arrows. That's a 3 and that's a 9, because 12 can be broken into 3 and 9. Okay, so I'll keep the 9 and I could remove the 3's from each side, and notice we'd have x equals 9. Okay. And again, we're going to have a fancy formal way of solving these later, but use these ideas. Use your idea of balance and equal and breaking and decomposing numbers to figure these out. And again, in this case, we were asked to solve. Okay. Now in this one, it's one of those equations that looks backwards, even though it's officially not backwards. Okay. So on the right, we have x, 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 7, and 3. Okay. So notice I have 3 copies of x, so I'm going to write this as 3x, and I can combine the 7 and 3 into one number, which is 10. They look better in boxes, so let me just put them in the boxes. Okay. So this expression is equal to 3x plus 10. And notice what I did. You could say I simplified because I performed all of the operations, or you could say I performed the operations, either one. Okay, so remember those are pretty much synonymous, simplifying or performing all the operations. Now let's look at one last error analysis. Okay, so this is something that starts to happen when you start solving equations in algebra, and you learn this new way of looking at the equation, and then you kind of forget the old way and you start looking at the new way and seeing everything that way. So let's see what I mean. So John was given the problem below. What does the equal sign symbol represent in this situation? So looking at this, it's likely, even though there's not directions, it's likely this is saying to simplify or perform the operations. So we would say there's 2 copies of x, which is 2x, minus 4. So I made an equivalent expression that's also the most simple expression. Okay. Now it says, John showed the work below. How was John misinterpreting the equal sign? How would you convince him to change his thinking? So let's see what John did. So John has 2x equals 4. Okay, so we have the expression 2x minus 4. How is he getting that 2x equals 4? Okay, so maybe you can see that John is thinking that since there's nothing here, it's an equation that equals 0. And let me put not true. Okay, so John thinks he's solving an equation equal to 0. Okay, so instead of evaluating this, even though the directions probably said evaluate or simplify, he sees this and he sees this new things. He sees this balanced equation, and on the right hand side there's nothing, and he thinks 0 is nothing, and then he basically balances the scale by saying, well, I have x and an x, and if I take away 4, he thinks, well, I could just add 4 to balance it. Okay, I know we haven't done officially this yet later, but maybe you could see to get rid of a negative 4, you could add a positive 4. And then he says, well, 2 of the same thing added together must give me x equals 2. Okay, so this is not an equation. Okay, you're simplifying an expression. So I want to remind you, read the directions. Okay. I know this is hard. Sometimes I skip the directions because I usually know what to do just by looking at the problem because I've done this a lot. But since you're new at this, make sure you read the directions, do what the directions say to do, and beware of these easy ways to trip up now that you're having this new understanding of the equal sign. I'll see you at the next video.